Hey, AP Chemisters, this is Mrs. Blankwalle bringing you the 4.4 edition of Blankwalle. This is about solution concentration and solution stoichiometry. So we do not lose our BCA table ideas here. We'll be using it at the end of the section. But before that, we have to know what solution concentration is. I don't know if you've noticed, but in the BCA tables that we did in section 4.2 and 4.3, they're always solids or perhaps gases. We never really dealt with solution chemistry, like aqueous. How do I deal with that information? How do I talk about moles of an aqueous solution if I only know the volume? Okay, how do I convert those? That's what this section's all about. So let's just talk about solutions real quick. Some vocabulary here. So a solution is a homogeneous mixture. Homogeneous mixture means it's uniform throughout. The solvent is majority component, what does the dissolving. The solute is a minority component, what is being dissolved. So example, you know me, I love my sweet tea. I used to make some every single morning using like a Lipton iced tea mix. And so what would be my solution? My solution is the final product, my sweet tea, yum yum. And so how did I make it? I put the tea mix, okay, so maybe in this case the sugar, there we go, into some water. So this could have the flavoring and all that kind of stuff. So that'd be my solute, that's my solvent. What do I have more of in my cup? Do I have more sugar or do I have more water? Well, unless I get really sick or something, let my blood sugar go crazy, I should have more water than my sugar. So this is my solute, this is my solvent. So what about the difference between concentrated versus dilute? If I look on the microscopic scale, a concentrated solute, all right, would be lots of molecules per given volume. A more dilute would be fewer molecules per given volume. Notice that these boxes are the same size. Here I have, looks like 8, let's say sugar molecules, if you will, in this same volume. Here I only have 4. So that's the idea of concentration. It's the amount per volume, all right? And how do we express concentration? Well, I need a guest speaker here. It's a protege of VV Mol to help us out with molarity. So hang on. So I want to thank Mr. CC Mol C for counter and Mr. AA Mol A. This is Andy Miller. And here's the mole right here. They're on top of a mountain in Germany. And so they sang the song for VV Mol B. That's awesome. Thanks, guys. So let's go back and see how we work this. So what did CC Mol C and AA Mol A tell us, all right? That they sung the moles on top of the mountain, all right? So if you have your little triangle here, put moles on top of the mountain, and you remember why the moles on top of the mountain? To see molarity and liters, all right? So you have to tag that at the end. And so how does this help me? If I want to know what molarity is, cover up the moles, cover this up, and it's moles per liter. What's liters is moles per molarity. What's moles, it's molarity times liters. And folks, I bet you'll be singing the song when you're in college one day, all right? So you're sitting in your chemistry class with 500 people surrounding you, and you're gonna burst out into the moles on top of the mountain song. I guarantee it, all right? So how does this help us? Well, let's do some math, okay? All right, so calculate the molarity of a solution prepared by dissolving 11.5 grams of solid sodium hydroxide in enough water to make 1.5 liter solution. So I'm looking for molarity. All right, I'm ready. So here's molarity, is moles per liter, right? So molarity, cover up molarities, moles on top of liters. Good, so let's see here. I'm reading the problem and Mrs. Blankwalle, there's no moles. What am I supposed to do? Well, I got grams. Periodic table. All right, can you figure out moles given grams? I sure hope so. So question mark moles equals 11.5 grams. Grams of what? Sodium hydroxide. If you don't already have a periodic table in a calculator, you probably need to get one out at this point, all right? So if you need to pause this, grab your stuff, do this and come back, all right? Okay, hopefully you got everything. So what do I put on the bottom? I put grams of sodium hydroxide. So did you find the molar mass of sodium hydroxide? 1 sodium, 1 oxygen, 1 hydrogen? I got 40. All right, what goes on top is 1 mole. And what does this equal? Hey, you calculate it, not me. I got 0.288. I did calculate it, haha. Okay, so now can we go fill in this? I think we can. So molarity is equal to moles per liter, and moles is 0.288 from over here, right? What's my liters? Right here is 0.150. And when you calculate it out, you get 0.192 molarity. Okay, that's not too bad. So I don't have to give you moles. I can give you grams, and periodic table, you can find your moles. Okay, from there, you can find the rest. Let's go on the next page. All right, so problem number 14, calculate the molarity of a solution prepared by dissolving 1.56 grams, should be of, not or, gaseous HCl in enough water to make 26.8 milliliters of solution. I think you can do this by yourself. So why don't you pause this, I mean it, and when you're ready, come back. Okay, how'd you do? Well, let's find out. Let's scroll this down. And the answer is, here we go. They didn't give you moles, so they gave you grams. I had to find the molar mass of HCl, and I got 0.0428 moles. And here's my molarity, moles per liter. Here's my moles. But wait a minute. What is this? 26.8 milliliters? What do I have to do? I have to divide that by 1,000 or move the decimal place over 3 spots to get 0.0268 liters. And now when I'm all done, I got 1.60 molar HCl. Okay, so that'd be my solution concentration. Okay, so now problem 15, let's check this one out. So they're asking you something different. How many liters? Go back and look at your triangle again. What is the formula for liters? The mole's still on top of the mountain, but this time it's moles per. Okay, I'm not sure I just left off here. So, all right, so how many liters are in 0.125 molar NaOH? Contains 0.255 moles of sodium hydroxide. All right, so I'm looking for liters. So look at your triangle again. The mole's on top of the mountain, but this time what is liters equal to? Liters is equal to moles per molarity. So what do I have? I have molarity and I have moles. I don't have to do anything funky, do I? All right, I just plug these numbers into the equation and there I go. That wasn't too bad. All right, so problem number 16 is super duper important. Will you star this, highlight this, whatever you need to do to this so this really makes sense to you? I will probably readdress this question with you next time we meet because this is important, okay? And you can solve this by factor labeling, folks. Factor labeling can help you with so many things as long as you label everything. That's why it's called factor labeling, all right? Don't be lazy. Make sure you put units on everything. So what are they asking you for? Find the concentration of each type of ion, not atom, ion, in 0.50 molar iron 3 perchlorate. So I'm going to start off here. So find the molarity. That's concentration, isn't it, molarity? And I start with 0.50 molar of iron 3, whatever, perchlorate. So now what? I need to, whoops, factor label. Here we go. I can factor label this. What unit has to go on the bottom? It is the molarity of iron 3 perchlorate. And so I'm going to do that. Now, this is the same idea as moles. If I have the same volume, would you agree that the ratio of moles is the same as the ratio of molarity? Would that work for you as long as we have the same volume? I'm hoping so. So if this were moles, if I had 1 mole of iron 3 perchlorate, how many moles of iron do I have? Well, how many irons are in the formula? Just 1. So if I have for every 1 mole of iron 3 perchlorate, I have 1 mole of iron ion. If I have 1 molar of iron 3 perchlorate, I have 1 molar iron. Because I have 1 iron in the formula, this works. Let me say this one more time. If you have the same volume, the ratio of molarities is equal to the ratio of the moles. So I'm allowed to do that, okay? And so what's my answer? This. Now watch what I do with the next one. What is the molarity of perchlorate ion? Not chlorine, not oxygen. They're asking for the entire ion. So once again, I'm going, oops, sorry for that. I'm going to get my line going here. Okay, what unit must go on the bottom is molarity of iron 3 perchlorate. Now what? What is the ratio of moles of perchlorate for iron 3 perchlorate? I have a subscript right here. Do you see that? So that means my ratio is 3 moles of perchlorate per 1 mole of iron 3 perchlorate. Therefore, my molarity has a ratio of 3 to 1 also. And so that's my answer. Okay, that is really important. Okay, so again, we'll talk more about this tomorrow in class, probably the next time we meet. Problem number 17 is very, very similar. Let's see how we work with this one. Read carefully. What are they asking you for here? Calculate the number of moles, not molarity, moles of chloride ions, and they gave us some information. So I need moles. What did they give us? They gave us molarity and they gave us volume. So can I find moles? Well, I sure hope so. Okay, so what am I going to do? So first I'm going to find moles of zinc chloride. From there, I'll do a mole ratio. And so what's that equal to? The moles on top of the mountain. Oh, there we go, molarity times liters, all right? So what is the molarity of this stuff, all right? Well, they gave me 1 times 10 to the negative 3, so I made it into normal sign or normal notation, times the volume, and that's what I get. This is randomly, my calculator gave me 0.00175. That's great, but how many sig figs are right here? 2, so I made it 2 sig figs, all right? So now what? That's how many moles of zinc chloride I have. That's not what they're asking you for. They're asking you for how many moles of chloride ions do I have. So I'm going to start with 0.0018 moles of zinc chloride. And now what? Well, I'm going to do this. And for every 1 mole of zinc chloride, what do I get? How many moles of chlorine do I have for every 1 mole of zinc chloride? Well, what's the subscript of chlorine? It's a 2. So I'm going to put 2 on top. So what am I going to do now? I'm going to multiply, and that's what I get. So notice by factor labeling, I answer my question. Here above, problem 16 is asked for molarity. Problem 17, I'm asked for moles of chloride. So there I have moles of chloride. So let's see what problem number 18 is all about. It's saying, whoops, hang on. Is to analyze the alcohol content of a certain wine, a chemist needs 1 liter of aqueous 0.2 molar potassium dichromate. How much solid potassium dichromate must be weighed out to make the standard solution? Well, you need moles, don't you? Well, do I weigh out moles on my scale? Do I have a mole meter someplace? Of course I don't. What do you have to weigh out? You have to weigh out grams, all right? So in order to find grams, we need to know the formula of potassium dichromate. So what is it? Did you get this? I sure hope so. So now what? Can we find the rest of the story? Why don't you pause this and work out the whole problem and see what you get. All right, so I need moles. Let's see, I have liters, I have molarity, so can I find moles? Yes, I can. There, I got moles. Now what? I need grams, periodic table. Well, what do I have to know? I have to know the molar mass in order to convert the 0.200 moles into grams. So let's do that. And here's my work. I got a molar mass of 294.2 grams per mole. And now can I figure out how many grams I should weigh out? And there I go. Notice I'm factor labeling. Please do that too, okay? I think this is a good place to stop. Let me check. I think this is a very good place to stop. So you'll look for part 2, but again, I'll end with don't wait to be great.